how do we solve this word problem? So, as you see here, this is a counting problem. So, what we're going to do first is understand how this game works and draw a diagram so it'll help us solve the problem. Okay, so we're first going to draw a diagram. We have these bins, A, B, C, D, E, and there's one ball being deposited in bin A. That's just ball number 1. There's 2 balls being deposited in bin B. That's 2 and 3. There's 3 balls being deposited in bin C. That's 4, 5, and 6. And we can see that there it keeps on going. Okay, so we're gonna label this. This is balls, number of balls deposited. How do you deposited? Number of balls deposited. Okay. Deposited in such bin. Okay. So obviously it repeats back to A, which 6, 7, 8, 9, and 10. And the reason we can make this much simpler on ourselves, we can add the number of balls deposited up into n, and it has to be around 2024. So around 2024, and this is the total number of balls deposited, and each of these numbers represents one bin. So that will also help us find the what the problem is asking for. Okay, so as you'll see, we can apply the sum formula. And obviously, don't memorize formulas. There's another way to prove it, easily to prove it. We can put these numbers in pairs and then multiply by the number of numbers and then divide by 2 because we're overcounting for the number of pairs. Okay, so n plus 1 divided by 2 times n, and that's just n squared plus n divided by 2. It has to be around 2024. And then we find that 4048 is around, it has to be n squared plus n has to be around 4048. And obviously you can use guess and check. It won't take that long. You'll see 60 is close, and then you'll find 63, and 63 is actually the closest, but it doesn't reach 4048 balls put in, total balls put in. So what we're calculating, actually, if I didn't explain it clearly enough, what we're calculating here is the number of balls put in. Total number of balls put in. It doesn't matter which bin, it's just the amount of balls we put into the bins in general. And so once we reach 63 balls put into one bin, see, we have 1 ball put into one bin, 2 balls put into one bin, 3 balls put into one bin, 63 balls put into one bin, whichever bin it is, will have something close to the number of balls we want to put in, which is 2024. But as you'll see, 63 and all the numbers up to it don't reach the total amount of balls put in, which is 2024 balls put in. So we'll actually have to see the 64th bin, because we'll be putting in around half the balls already put in of that 64, but it will have the 2024th ball. Okay, so I'm gonna erase all this to make our work area neater, and then all we have to do is find the 64th batch of balls, or 64th, which bin has 64 balls put into it. And as you see here, it repeats every 5, so we're adding every 5. We're adding 5 each round, and we'll have the 61st bin, 61 balls put into that first bin, we'll have 62 balls put into that second bin, which is bin B, 63 balls into a third bin, bin C, 64 balls put into the fourth bin, which is bin D. So we'll see that the answer is D. And obviously you can use modular arithmetic to solve this, but this is just a more logical approach, and you can see it very clearly, and it's pretty simple as well. Okay, so the answer is D.